They heard it before they understood what it meant. A sound like nothing they had experienced in combat before. Not the sharp crack of individual rifle shots they were accustomed to, but a sustained, rhythmic hammering that seemed to come from everywhere at once. 8 metallic pings, one after another, followed by brief silence, then the hammering resumed. Japanese soldiers crouched in their defensive positions on Guadalcanal that morning of August 7, 1942, tried to identify the source of this unfamiliar sound. Some thought it was a new type of machine gun. Others believed the Americans had brought some specialized weapon ashore with their landing force. They were wrong. What they were hearing was something their military leadership had dismissed as impractical, wasteful, and overcomplicated. They were hearing United States Marines firing M1 Garand rifles at a sustained rate that Japanese troops armed with bolt-action Arisaka rifles could not match, could not counter, and had not prepared for. Each ping they heard was an empty 8-round clip being ejected from a Garand after the last round was fired. Each burst of rapid fire represented a single American rifleman delivering aimed shots as fast as he could pull the trigger, without ever removing the rifle from his shoulder, without ever breaking his sight picture, without ever working a bolt. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Japanese soldiers facing this fire had been told that American infantry were poorly trained, that they relied on material superiority rather than skill, that their weapons were expensive and fragile. They had been assured that the Japanese Type 38 and Type 99 Arisaka rifles, proven designs based on sound engineering principles, were adequate for any combat they would face. The rifles were accurate, reliable, and simple. Most importantly, they reflected Japanese military philosophy: controlled fire, aimed shots, ammunition conservation, and the disciplined rifleman making every round count. But now, pinned down by fire that seemed continuous, unable to raise their heads without immediately drawing multiple shots, the soldiers were discovering that philosophy and reality were not the same thing. The Americans were not conserving ammunition. They were not firing slow, deliberate shots. They were pouring fire into Japanese positions with a volume and intensity that seemed impossible from individual riflemen. And they were doing it with standard-issue rifles, not specialized weapons or machine guns. This was not how infantry combat was supposed to work, not according to everything the Imperial Japanese Army had taught, believed, and built its doctrine around. But the sound kept coming, that distinctive ping of empty clips ejecting, the hammering of semi-automatic fire. And Japanese soldiers, pressed into the dirt and unable to return effective fire with their bolt-action rifles, began to understand that something fundamental had changed in infantry warfare, something their army had not prepared them for. The Japanese confidence in their bolt-action rifles was not blind faith or ignorance. It was based on decades of military experience, sound engineering principles, and a coherent philosophy of infantry combat that had proven effective in multiple wars. To understand why Japanese soldiers went into World War II armed with bolt-action rifles, while their primary adversary had equipped nearly every infantryman with a semi-automatic weapon, one must understand the thinking behind Japanese small arms development. The Arisaka rifle family traced its lineage to 1897, when Colonel Nariakira Arisaka supervised the development of what would become the Type 30 rifle. This weapon, chambered in 6.5mm, represented Japan's first domestically designed military rifle. Prior to this, Japanese forces had used foreign weapons or close copies of European designs. The Type 30 established design principles that would carry through to World War II: a strong bolt action capable of handling high-pressure cartridges, a simple feeding system that was reliable under field conditions, and construction that could be maintained with minimal tools and training. The Type 38 rifle, adopted in 1905 and designated according to the Japanese imperial calendar as the 38th year of Emperor Meiji's reign, refined the design. It remained chambered in 6.5mm, a relatively mild cartridge that produced manageable recoil and allowed for accurate shooting by soldiers of smaller stature. The rifle was long, measuring 50 inches with its bayonet attached, reflecting Japanese doctrine that emphasized the bayonet as a primary infantry weapon. The Type 38 saw extensive combat in the Russo-Japanese War of 1904 to 1905, where it performed admirably. Japanese infantry, armed with Type 38 rifles, defeated Russian forces equipped with the M1 Garand, itself a robust bolt-action design. The victory validated Japanese small arms philosophy. The rifle was accurate, reliable in harsh conditions, and simple enough that conscript soldiers could be trained to use it effectively. Most importantly, it worked. Japan had defeated a European power, and the weapons their infantry carried had proven adequate to the task. This success created a pattern of thinking that would persist for decades. Japanese military planners saw no reason to fundamentally change a system that had delivered victory. Improvements could be made, certainly. The Type 99 rifle, adopted in 1939, switched to a more powerful 7.7mm cartridge after experience in China suggested that the 6.5mm round lacked stopping power. But the fundamental mechanism remained the same, a bolt-action rifle that required the soldier to manually cycle the action between each shot. The Japanese were not alone in this thinking. In 1939, when World War II began in Europe, every major military power armed its infantry primarily with bolt-action rifles. The Germans used the Mauser 98K. The British carried the Lee Enfield. The Soviets had the M1 Garand. The Italians fielded the Carcano. The French used the MAS 36. Even the United States, despite having adopted the M1 Garand in 1936, had not yet fully equipped its forces with the new rifle when war began. Bolt-action rifles represented mature technology. They were understood, reliable, and proven in combat across multiple conflicts and continents. The mechanism was simple enough that it could be manufactured with relatively basic machine tools, maintained in field conditions with minimal specialized equipment, and repaired by unit armorers without need for factory support. For nations with limited industrial capacity or resources, these were not minor considerations. Japanese military theorists were aware of semi-automatic rifle development in other nations. They were not ignorant of American efforts to field the M1 Garand or of German experiments with semi-automatic designs. But they viewed these efforts with skepticism rooted in practical considerations and military philosophy. The arguments against semi-automatic rifles, as articulated in Japanese military publications and training materials from the 1930s, were logical and, within their framework of assumptions, entirely reasonable. First, there was the question of ammunition consumption. A soldier armed with a semi-automatic rifle could fire as fast as he could pull the trigger. Japanese planners calculated that this would lead to enormous increases in ammunition expenditure without corresponding increases in combat effectiveness. A trained rifleman, they argued, should fire aimed shots at identified targets. Rapid fire, without careful aim, was wasteful and ineffective. The Type 38 rifle held 5 rounds in an internal magazine loaded via stripper clips. The Type 99 held the same. This was considered adequate because doctrine emphasized fire discipline. Each soldier was expected to identify targets, aim carefully, and make his shots count. Japanese infantry training reflected this philosophy. Recruits spent extensive time on marksmanship, learning to judge distance, account for wind, and deliver accurate fire at ranges exceeding 300 meters. The emphasis was on precision, not volume. Battalion commanders calculated ammunition requirements based on the assumption that each soldier would fire perhaps 30 to 50 rounds during an average engagement. Issuing every infantryman a semi-automatic rifle that could empty its magazine in seconds seemed like an invitation to waste precious ammunition. Second, there was concern about mechanical complexity and reliability. Semi-automatic rifles required gas systems or recoil mechanisms to cycle the action automatically. These systems introduced additional parts, tighter tolerances, and more opportunities for mechanical failure. Japanese military engineers, working within an industrial base that struggled to produce sufficient quantities of even basic weapons, viewed this complexity with alarm. A bolt-action rifle that jammed could often be cleared by the soldier manually working the bolt. A semi-automatic rifle with a failed gas system became a single-shot weapon at best, or a useless piece of metal at worst. The Japanese military had extensive experience fighting in China, Manchuria, and Southeast Asia. These were environments where dust, mud, humidity, and temperature extremes tested equipment to destruction. Weapons needed to function after being submerged in rice paddies, caked in volcanic ash, or exposed to monsoon rains for days. The simpler the mechanism, the more likely it would continue functioning under these conditions. Engineers at the Kokura Arsenal and Nagoya Arsenal, responsible for rifle production, advised military planners that semi-automatic rifles would require more careful maintenance, more frequent parts replacement, and more specialized training than bolt-action weapons. Third, there was the question of industrial capacity. Japan's factories in the late 1930s were already strained, producing rifles, machine guns, artillery pieces, vehicles, aircraft, and naval vessels. The invasion of China in 1937 had created enormous demand for weapons of all types. Adding a complex new rifle to production lines would require retooling factories, training new workers, and diverting resources from other programs. Japanese military planners faced difficult choices about resource allocation. Should they produce more bolt-action rifles that could be manufactured quickly and cheaply, or fewer semi-automatic rifles that cost more in materials, labor, and time? The calculus seemed clear. Bolt-action rifles could be produced in larger numbers, issued to more soldiers, and supported with the existing logistics and training infrastructure. Semi-automatic rifles offered increased firepower for individual soldiers, but at costs that seemed prohibitive given Japan's industrial constraints. When military theorists conducted cost-benefit analyses, the bolt-action rifle appeared to be the rational choice. There was also a philosophical dimension to this decision that went beyond purely practical considerations. Japanese military culture emphasized spiritual factors in combat effectiveness. The concept of seishin, or fighting spirit, held that properly trained and motivated soldiers could overcome material disadvantages through superior morale, discipline, and willingness to close with the enemy. Firepower was important, certainly, but it was not the decisive factor. The decisive factor was the quality of the men wielding the weapons. This philosophy suggested that issuing soldiers semi-automatic rifles might actually reduce combat effectiveness by encouraging them to rely on mechanical firepower rather than developing the discipline and skill that made a truly effective infantryman. Better to have soldiers who could deliver accurate fire with bolt-action rifles and who possessed the spirit to charge with bayonets when necessary than soldiers who sprayed bullets from semi-automatic weapons without proper aim or discipline. While Japanese military planners were refining their bolt-action rifles and calculating ammunition expenditure rates, American ordnance engineers were pursuing a fundamentally different vision of infantry firepower. The story of the M1 Garand rifle begins not with a single decision but with decades of experimentation, false starts, and persistent belief that semi-automatic rifles represented the future of infantry combat. John Cantius Garand, a Canadian-born engineer working at the Springfield Armory in Massachusetts, had been developing semi-automatic rifle designs since 1919. His early prototypes were promising but flawed. They were too heavy, too sensitive to ammunition variations, or too complex for mass production. But Garand persisted, refining his gas-operated design through countless iterations. By 1928, he had developed a rifle that caught the attention of Army ordnance officials, serious enough to warrant continued development funding. The rifle that would eventually become the M1 used a gas-operated system that was elegant in its simplicity. When a cartridge fired, a portion of the propellant gas was diverted through a port in the barrel into a gas cylinder located beneath the barrel. This gas drove a piston rearward. The piston was connected to an operating rod that rotated and unlocked the bolt, extracted and ejected the spent cartridge case, cocked the hammer, and on its return stroke chambered a fresh round from the 8-round en bloc clip. The entire cycle took a fraction of a second and occurred automatically every time the trigger was pulled. American ordnance officers saw potential in Garand's design, but they also had concerns similar to those expressed by Japanese planners. Would semi-automatic rifles waste ammunition? Would they be reliable under field conditions? Could American industry produce them in sufficient quantities? The difference was that American military leadership decided these concerns could be addressed through engineering and industrial planning rather than accepting them as insurmountable obstacles. The Army conducted extensive trials throughout the early 1930s. Garand rifles were tested in desert conditions at Fort Benning, Georgia, in cold weather at Aberdeen Proving Ground, Maryland, and in tropical environments that simulated Pacific Island conditions. Engineers deliberately subjected the rifles to abuse, dropping them, submerging them in water, coating them in sand and mud, and firing thousands of rounds without cleaning. The goal was not to prove the rifle would never fail, but to identify failure modes and design solutions. Problems emerged during testing. The original design used a different operating system that proved unreliable. Garand redesigned the gas system. The rifle was too heavy. Engineers reduced weight by modifying the stock and trigger assembly. The en-bloc clip system, which held 8 rounds and was inserted as a complete unit into the rifle's internal magazine, sometimes caused feeding problems. The clip design was refined multiple times until it functioned reliably. By 1936, the rifle had evolved into a form that Army ordnance officials believed was ready for adoption. On January 9, 1936, the M1 rifle was officially adopted as the standard service rifle for the United States Army. The designation M1 simply meant Model 1 in the New Year's adoptions. It was the first semi-automatic rifle to be adopted as a standard service weapon by any nation's military. Adoption was one thing. Production was another. Springfield Armory, the government facility that had manufactured American military rifles since 1794, began producing M1 rifles in 1937. Initial production was slow. The rifle required precision machining on components like the gas cylinder, operating, rod, and bolt. Workers needed training on new manufacturing processes. Quality control standards were exacting because any dimensional variation in critical parts could cause reliability problems. Production in 1937 totaled approximately 1,000 rifles. In 1938, production increased to about 5,000. These were tiny numbers compared to the hundreds of thousands of rifles that would eventually be needed to equip American ground forces. But Army planners were not concerned about immediate numbers. They were investing in industrial capacity and worker training, knowing that if war came, production could be expanded. Winchester Repeating Arms Company received a contract in 1939 to begin producing M1 rifles, supplementing Springfield Armory's output. Winchester engineers studied the Springfield production methods and created their own manufacturing processes. By 1940, with war raging in Europe and American military expansion beginning, combined production from both facilities reached approximately 50,000 rifles. This was still far short of what would be needed to equip the entire Army, but the production infrastructure was being established. The rifle that emerged from these production lines weighed 9.5 pounds unloaded. It measured 43.6 inches in overall length. The barrel was 24 inches long and rifled with 4 grooves, making one complete turn in 10 inches to stabilize the bullet. The rifle fired the .30-06 Springfield cartridge, a powerful round that had been American military standard since 1906. The cartridge fired a 150-grain bullet at a muzzle velocity of approximately 2,800 feet per second, delivering substantial energy at ranges exceeding 500 yards. The Japanese soldiers who landed on Guadalcanal in the summer of 1942 were confident, experienced troops. Many had fought in China. They were accustomed to victory. Their officers had told them that American soldiers were soft, poorly trained, and would break under determined attack. The Americans had achieved some early successes in the Pacific, certainly, but these were attributed to material advantages and luck rather than genuine military capability. Japanese infantry, properly led and motivated by Bushido spirit, would prevail in close combat. The initial landings by US Marines on August 7th caught Japanese forces by surprise. The Americans came ashore in division strength, overwhelming the small Japanese garrison on the island and quickly capturing the nearly completed airfield that would be renamed Henderson Field. But Japanese commanders viewed this as a temporary setback. Reinforcements would arrive, the Americans would be driven off, and the strategic position would be restored. It was simply a matter of bringing sufficient force to bear. What the Japanese did not fully understand was what they would face when their reinforcements engaged American Marines in sustained infantry combat. The Marines who came ashore on Guadalcanal were armed almost entirely with M1 Garand rifles. Some specialized troops carried M1903 Springfield bolt-action rifles as sniper weapons, or because Garands were not yet available in sufficient numbers for complete re-equipment. But the standard Marine rifleman carried an M1 Garand, 8 rounds in the magazine, and additional 8-round clips in canvas bandoliers and cartridge belts. The first major engagement came on August 21st, when Japanese forces under Colonel Kiyonao Ichiki attacked Marine positions along the Ilu River. Ichiki's force numbered approximately 900 men from the 28th Infantry Regiment, veteran troops who had fought in China and participated in the invasion of Guam. They were armed with Type 38 Arisaka rifles, Type 96 and Type 99 light machine guns, and grenades. Their plan was to conduct a night attack, relying on surprise and aggressive tactics to overwhelm the American positions before the Marines could organize effective resistance. The attack began shortly after midnight. Japanese soldiers advanced through the darkness, moving as quietly as possible through the jungle vegetation toward Marine lines. American sentries heard movement and fired illumination rounds. Suddenly the battlefield was lit by the harsh white light of parachute flares drifting slowly earthward. Japanese soldiers, now visible and exposed, had no choice but to charge forward, hoping to close with the Marines before defensive fire could cut them down. What happened next was something Japanese military doctrine had not prepared them for. Marine riflemen, instead of firing individual aimed shots at a measured pace as Japanese soldiers expected from their own training, opened fire with a volume and intensity that seemed impossible from infantry rifles. The distinctive sound of M1 Garands firing semi-automatically created a sustained roar of rifle fire that Japanese veterans later compared to machine gun fire. Marines could fire the 8 rounds in their Garand as fast as they could acquire targets and pull the trigger. An average rifleman could empty the 8-round clip in perhaps 5 to 7 seconds with aimed fire. The empty clip then ejected automatically with a distinctive metallic ping. The Marine inserted a fresh 8-round clip, released the bolt, and was immediately ready to fire again. The entire reload process took perhaps 3 to 5 seconds for a trained man. Within 12 to 15 seconds, a Marine rifleman could fire 8 rounds, reload, and fire again. Japanese soldiers, armed with Type 38 Arisaka rifles, could fire at nowhere near this rate. After each shot, the soldier had to lift the bolt handle, pull it rearward to extract the spent cartridge case, push it forward to chamber a fresh round from the internal magazine, and push the bolt handle down to lock it. An experienced soldier could do this quickly, perhaps achieving a sustained rate of 10 to 12 rounds per minute with aimed fire. But this was less than 1/4 the rate a Marine could achieve with the M1 Garand. The mathematics of this firepower disparity became brutally clear in combat. A Marine squad of 13 men, all armed with M1 Garands, could deliver over 100 aimed shots in the first 15 seconds of contact. A Japanese squad of the same size, armed with bolt-action rifles, could deliver perhaps 30 shots in the same period. The Americans had more than 3 times the firepower at the individual rifleman level, before accounting for any machine guns, mortars, or other support weapons. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. At the Ilu River, this firepower advantage devastated the Japanese attack. Illuminated by flares and caught in the open, Japanese soldiers trying to cross the river or advance through the sparse cover were hit by sustained rifle fire from Marines who never had to take their weapons off their shoulders to reload. Men fell in groups. The attack stalled, reorganized, and came again. Marine riflemen fired until their barrels were too hot to touch, then continued firing. Ammunition bearers brought forward fresh bandoliers of 8-round clips. By dawn on August 21st, the Battle of the Tenaru River, as Marines called it, was over. Of the approximately 900 Japanese soldiers who had attacked, over 800 were dead. The Marines had suffered 19 killed and 57 wounded. It was not simply a defeat for Japanese forces. It was a revelation of fundamental inadequacy in their basic infantry weapons and tactics. Japanese survivors who made it back to their lines told stories that seemed impossible to their officers. They described Americans who fired continuously without pause, who never seemed to need to reload, who poured fire into attacking formations with a volume that no bolt-action rifle could match. Some officers dismissed these accounts as exaggerations born from the trauma of defeat. Others began to understand that they faced a problem with no easy solution. Colonel Ichiki himself did not survive to report his observations. He committed suicide after the battle's outcome became clear, taking responsibility for the disaster in the traditional manner expected of Japanese officers. But other officers who witnessed the engagement or interrogated survivors began compiling reports that made their way up the chain of command. These reports noted the Americans' semi-automatic rifles and attempted to assess their impact on combat effectiveness. Japanese military intelligence had known about the M1 Garand before the war. Samples had been obtained and examined. But knowing a weapon existed and understanding its tactical implications in actual combat were different matters. Pre-war assessments had acknowledged the Garand's firepower advantage, but had concluded that this advantage was offset by the weapon's complexity, cost, and the ammunition consumption it would create. Japanese planners had assumed that American logistics could not sustain the ammunition expenditure rates that semi-automatic rifles would generate in sustained combat. They were wrong about American logistics. The United States industrial base could not only produce M1 Garand rifles in enormous quantities, it could also produce the ammunition to feed them. Lake City Army Ammunition, plant in Missouri, built in 1941 specifically to manufacture small arms ammunition, had a production capacity exceeding 1 billion rounds per year when operating at full capacity. Frankfort Arsenal in Pennsylvania, Denver Ordnance Plant in Colorado, and other facilities added additional production. By 1943, American ammunition production exceeded 2 billion rounds of .30-06 ammunition annually. This production capacity meant that American combat units never faced ammunition shortages of the kind that Japanese planners had assumed would limit semi-automatic rifle effectiveness. Marines on Guadalcanal received regular ammunition resupply by ship and air. Each Marine carried typically 80 to 100 rounds of rifle ammunition in combat, with additional ammunition stored at company and battalion level. When units engaged in heavy combat, ammunition expenditure was replenished within days or even hours. Japanese forces on Guadalcanal, by contrast, struggled with ammunition shortages throughout the campaign. Resupply attempts by ship and submarine were hazardous and often failed. Individual soldiers were instructed to conserve ammunition, firing only when they had clear targets and a high probability of hits. This conservation mindset, which had been part of Japanese military culture even before supply problems emerged, was now enforced by necessity. The irony was profound. Japanese military doctrine had emphasized ammunition conservation and fire discipline as virtues that would give their infantry an advantage over wasteful American forces. But in reality, American industry could supply ammunition in such abundance that individual riflemen could fire whenever tactically useful without concern for running out. Japanese soldiers, forced by logistics constraints to carefully husband every round, found themselves outgunned by Americans who could afford to expend ammunition freely. As the Guadalcanal campaign continued, through the fall and winter of 1942 into early 1943, Japanese forces launched multiple attacks attempting to recapture Henderson Field and drive the Americans off the island. Each attack followed a similar pattern. Japanese infantry, motivated by desperate courage and Bushido spirit, would advance against Marine positions. Marine riflemen would engage with sustained semi-automatic fire that Japanese bolt-action rifles could not match. Japanese attacks would falter under this fire, suffering catastrophic casualties. On October 23rd and 24th, Japanese forces launched a major offensive with the 2nd Division, approximately 7,000 troops attacking across the Matanikau River. Marines defending the perimeter dug into prepared positions, engaged the attackers with M1 Garands, Browning automatic rifles, and machine guns. The rifle fire was so intense that Japanese soldiers reported they could not advance because the volume of incoming fire made movement impossible. Officers ordering banzai charges watched their men cut down before they could close with American lines. Individual Japanese soldiers who survived these attacks and were later captured, or who kept diaries that were recovered after the war, described their experiences in terms that revealed deep psychological impact. They had been trained to believe that Japanese infantry were superior in close combat, that spiritual strength could overcome material disadvantages, that properly executed attacks would overwhelm any defender. But they discovered that courage was not enough when facing an opponent who could fire 8 aimed shots in the time it took to fire 2. One captured Japanese soldier, a private who had been wounded and left behind when his unit withdrew, told Marine interrogators through a translator that he had initially thought the rapid fire he heard was from American machine guns. When he realized it was rifle fire, individual Marines firing, semi-automatic weapons, he said he felt a sense of despair that he had never experienced in previous combat. His own rifle, which had seemed adequate in China, suddenly felt obsolete. He described trying to work his bolt quickly enough to return effective fire, but knowing even as he did so that the American firing at him would get off 3 or 4 shots in the time it took him to fire once. Japanese military leadership recognized the problem. Reports from Guadalcanal and subsequent Pacific battles consistently noted American semi-automatic rifle superiority. Intelligence officers compiled detailed assessments of the M1 Garand's specifications, capabilities, and tactical impact. Engineering teams examined captured Garands when they could be recovered from battlefields. The question was not whether the Garand gave Americans a significant advantage. The question was what Japan could do about it. The answer, ultimately, was very little. Japan's industrial capacity was already strained to the breaking point by 1943. Factories were producing aircraft, naval vessels, artillery, vehicles, and conventional weapons at rates that consumed available raw materials, skilled labor, and manufacturing capacity. Adding a new semi-automatic rifle to production would require resources that simply did not exist. Steel allocation, machine tool availability, and worker training were all constrained by existing commitments. Japanese engineers did attempt to develop semi-automatic rifle designs. The Type 4 rifle, also known as the Type 5 inches, some documentation, was a semi-automatic design based loosely on the American M1 Garand's operating principles. Prototypes were built and tested at Kokura Arsenal in 1944 and early 1945. The rifle used a gas-operated system and fed from a 10-round detachable box magazine rather than the Garand's 8-round en-bloc clip. In testing, the rifle functioned adequately, though not with the reliability that the M1 Garand had achieved through years of refinement. But only a handful of Type 4 rifles were ever produced, perhaps fewer than 250 total before the war ended. They were manufactured primarily for testing and evaluation, not for field issue. The reasons were practical and insurmountable. Each Type 4 rifle required approximately twice the machine time to produce as a Type 99 Arisaka bolt-action rifle. The Type 4 used more steel and required tighter tolerances on critical components. At a time when Japan was struggling to produce enough conventional rifles to arm its expanding military, diverting resources to semi-automatic rifle production was impossible. There was also the matter of ammunition consumption. Japanese military logistics officers calculated that if infantry units were equipped with semi-automatic rifles, ammunition expenditure would increase by a factor of 3 to 5 times current rates. The logistics system was already failing to deliver adequate ammunition to frontline units. Shipping was constrained by American submarine warfare, which was strangling Japan's merchant marine. Raw materials for ammunition production, particularly copper for cartridge cases and lead for bullets, were increasingly scarce. Manufacturing facilities for ammunition were being damaged by American bombing raids. Even if Japan could somehow produce semi-automatic rifles in quantity, the logistics system could not support them with adequate ammunition. The entire military infrastructure, from ammunition production through transportation to frontline distribution, was built around assumptions of ammunition consumption that bolt-action rifles generated. Changing to semi-automatic rifles would require rebuilding this infrastructure, which was impossible given Japan's deteriorating strategic position. Some Japanese officers proposed alternative solutions. Perhaps semi-automatic rifles could be issued selectively to elite units or specialized assault troops rather than attempting to re-equip the entire infantry. But even this limited approach faced problems. Which units would receive the scarce semi-automatic rifles? How would they be maintained when spare parts were unavailable? How would ammunition supply be managed when different units had vastly different consumption rates? Meanwhile, American production of M1 Garands accelerated throughout the war. Springfield, Armory, and Winchester were joined by additional contractors. By 1943, monthly production exceeded 100,000 rifles. By 1944, production peaked at over 130,000 rifles per month. The United States was producing more M1 Garands every month than Japan had produced Type 4 semi-automatic rifles during the entire war. The disparity extended beyond the rifles themselves to the entire system that supported them. American factories produced the ammunition in billions of rounds. American ships transported it across the 60 Pacific without significant loss despite Japanese submarine attempts at interdiction. American logistics units distributed it to frontline troops with efficiency that Japanese planners could only envy. The M1 Garand was not just a superior rifle, it was the product of an industrial system that could design, produce, and support advanced weapons in quantities that overwhelmed any opponent. Japanese soldiers throughout the Pacific Theater fought the remainder of the war with essentially the same bolt-action rifles they had carried at the war's beginning. Some units received newer Type 99 rifles to replace older Type 38 seconds, but the fundamental mechanism remained unchanged. Individual soldiers developed techniques to try to increase their rate of fire, manipulating the bolt with practiced speed and learning to reload from stripper clips without taking their eyes off the target. But technique could not overcome the mechanical limitation that each shot required manual operation of the bolt. For Japanese infantry who survived multiple engagements against American forces, the knowledge that their rifles were inferior to those of their opponents created a psychological burden that military leadership struggled to address. Japanese military culture emphasized spiritual strength and fighting spirit as the decisive factors in combat. Soldiers were taught that superior morale, discipline, and willingness to sacrifice would overcome material disadvantages. But this belief became increasingly difficult to maintain when the material disparity was so obvious and so directly connected to survival. A Japanese soldier facing an American Marine in a firefight knew that the American could fire 8 rounds before needing to reload, while he could fire perhaps 2 or 3 in the same time. This was not a subtle difference, requiring analysis to understand. It was immediate, visceral, and undeniable. Every engagement reinforced the reality that American riflemen had a fundamental advantage that no amount of training or spirit could negate. Diaries recovered from Japanese soldiers killed in battles from Tarawa to Saipan to Iwo Jima contain entries describing their feelings about facing American firepower. These personal writings, never intended for anyone else to read, reveal the psychological impact of fighting with inferior weapons. One sergeant in the 109th Division wrote in his diary on Peleliu in September 1944 that he dreamed of capturing an American rifle so he could fire as quickly as the Marines who had attacked his position. He described feeling helpless, working his bolt frantically while Marines fired continuously. Another soldier, a corporal in the 32nd Army on Okinawa, wrote that he had been told American soldiers were weak and relied on machines rather than fighting spirit. But after several weeks of combat, he wrote that he would gladly trade all the fighting spirit in the Japanese army for a rifle that could fire without working the bolt. His entry concluded with a statement that morale and courage meant nothing when you were dead before you could chamber your second round. These were not isolated sentiments. American interrogators who questioned Japanese prisoners of war throughout the Pacific Campaign consistently noted that captured soldiers expressed admiration for American weapons, particularly the M1 Garand. Many prisoners asked detailed questions about how the rifle worked, how it could fire so quickly, and how Americans could afford to supply so much ammunition. The questions revealed a profound sense of having been misled by their own propaganda and leadership. Japanese officers faced an impossible situation. They could not tell their men the truth, that Japan's industrial capacity was inadequate to produce weapons comparable to those the Americans fielded. Admitting this would destroy morale and undermine the carefully constructed narrative that spiritual strength would lead to victory. But they also could not deny the obvious reality that their soldiers faced in combat. The compromise was to emphasize that Japanese soldiers must fight harder, show more courage, and be willing to close with the enemy where the rifle's rate of fire mattered less. This led to increasing emphasis on night attacks, infiltration tactics, and banzai charges designed to close the distance before American firepower could be brought to bear effectively. But these tactics had their own terrible costs. Night attacks were difficult to coordinate and often resulted in Japanese units becoming disorganized in the darkness. Infiltration tactics required extensive training and reconnaissance that frontline units often lacked. Banzai charges, while sometimes achieving surprise and local success, generally resulted in catastrophic casualties when they failed. On Saipan in June and July 1944, Japanese forces launched multiple banzai charges attempting to break through American lines. The largest occurred on July 7th, when approximately 3,000 Japanese soldiers, including many wounded men from field hospitals who could barely walk, charged American positions. Marine and Army units, armed with M1 Garands, Browning automatic rifles, and machine guns, opened fire at ranges of 100 to 200 yards. The sustained fire was so intense that Japanese survivors later reported seeing men simply disappear in the volume of incoming bullets. The charge failed completely. Over 2,000 Japanese soldiers died in approximately 30 minutes of combat. American casualties were significant but far lower, partly because the Americans' superior firepower allowed them to engage attacking forces at longer ranges and sustain higher rates of fire throughout the engagement. A Marine lieutenant who participated in defending against the charge later wrote that his riflemen fired so many rounds that the barrels of their M1 Garands were too hot to touch. Empty 8-round clips littered the ground around fighting positions in piles. When the war ended in August 1945, the United States had produced approximately 4 million M1 Garand rifles. These weapons had served in every theatre, from the beaches of Normandy to the jungles of Burma to the volcanic islands of the Pacific. General George Patton, commanding the Third Army in Europe, called the M1 Garand the greatest battle implement ever devised. His assessment was based not on sentiment but on observed performance. American infantry armed with Garands had consistently outfought German infantry armed with Mauser 98K bolt-action rifles in sustained firefights. In the Pacific, where Japanese forces never fielded semi-automatic rifles in meaningful numbers, the disparity was even more pronounced. American Marines and Army infantrymen had a fundamental firepower advantage at the individual rifleman level that influenced every engagement. This advantage did not make American forces invincible or guarantee victory in every battle. Japanese forces fought with extraordinary courage and determination throughout the war, achieving local successes and inflicting heavy casualties on American units. But the rifle firepower disparity meant that in sustained infantry combat, American forces could deliver more aimed shots per minute than their opponents, and this mattered. After the war, military analysts studying infantry combat effectiveness concluded that the M1 Garand had increased American infantry firepower by approximately 300% compared to bolt-action rifles. This figure accounted for the faster rate of fire, the ability to keep the rifle shouldered during reloading, and the psychological advantage of knowing you could engage targets rapidly without manual bolt operation. Some studies suggested the advantage was even greater in close-range combat, where rapid engagement of multiple targets was necessary. The lessons were not lost on other nations. The Soviet Union, which had used primarily bolt-action Mosin Nagant rifles during World War II, developed the SKS semi-automatic rifle and then the AK-47 select-fire rifle in the immediate post-war period. The British, who had relied on the excellent but still bolt-action Lee Enfield rifle, developed semi-automatic designs, though they would not fully adopt one until the 1952nd. Even nations with limited industrial capacity recognized that semi-automatic rifles represented the minimum acceptable standard for modern infantry weapons. Japan's failure to develop and field semi-automatic rifles during World War II was not the result of ignorance or inability to understand the technology. Japanese engineers were capable of designing semi-automatic rifles, as the Type 4 demonstrated. The failure was rooted in industrial capacity, resource constraints, and strategic decisions made years before the war began. Japan had chosen to prioritize naval and air power over ground forces modernization. When war came, the nation discovered that this choice had consequences that could not be reversed through courage or tactical skill. For the individual Japanese soldiers who fought with bolt-action rifles against American troops armed with M1 Garands, the experience was one of profound disillusionment. They had been told their weapons were adequate, that spiritual strength mattered more than material superiority, that Japanese infantry were the finest in the world. Combat revealed that these assurances were false. Their rifles were not adequate. Spiritual strength could not overcome a 3-to-1 firepower disadvantage. And being the finest infantry in the world meant nothing when you were dead before you could chamber your third round. The sound that Japanese soldiers heard on Guadalcanal that August morning in 1942, the rhythmic hammering of M1 Garands firing in semi-automatic mode, was the sound of their assumptions shattering. It was the sound of industrial warfare's reality, overwhelming military tradition and doctrine. It was the sound of a weapon system so superior to what they carried that no amount of training or courage could compensate for the difference. And it was a sound that would echo across every Pacific battlefield for the next 3 years, a constant reminder that in modern war, industrial capacity and technological superiority could be as decisive as any human factor. The M1 Garand was not a perfect weapon. It had limitations. The 8-round en-bloc clip could not be topped off with individual rounds. The distinctive ping when the clip ejected could theoretically alert nearby enemies that the rifle was empty, though in practice the noise of combat made this largely irrelevant. The rifle was heavy compared to some contemporary designs. But it was reliable, accurate, and above all, it gave American infantrymen a rate of fire that enemies armed with bolt-action rifles could not match. Japanese military planners had dismissed the M1 Garand as too complex, too expensive, and too wasteful of ammunition. They had been correct about the complexity and expense. American industry had invested enormous resources in developing and producing the rifle, but they had been catastrophically wrong about the value proposition. The Garand's advantages in combat far outweighed its costs in production, and the assumption that ammunition consumption would be unsustainable proved completely false when confronted with American industrial capacity. The story of the M1 Garand in the Pacific is ultimately a story about the importance of industrial capacity in modern warfare. It demonstrates that technological superiority at the individual weapon level, when multiplied across millions of soldiers and supported by adequate logistics, creates advantages that cannot be overcome by doctrine, training, or morale alone. Japanese soldiers learned this lesson in the most brutal way possible, through repeated combat experiences where they faced opponents who could fire 3 times as fast as they could. Those who survived carried the knowledge with them for the rest of their lives. The rifle that their military leadership had dismissed as impractical had proven devastatingly effective. The industrial system they had been told could not sustain such weapons had produced them in millions. And the assumptions they had been taught about spiritual strength overcoming material disadvantages had been shattered by the simple, undeniable mathematics of 8 rounds, fired as fast as you can pull the trigger. Thank you for watching. For more detailed historical breakdowns, Check out the other videos on your screen now, and don't forget to subscribe.